Did you know that 3.14% of sailors are pirates? Now you do. Arr, arr, arr. Alright, what's going on, Algebra Bros? It's Mr. C here, and in this video I am going to derive the difference quotient. Now, just exactly what is the difference quotient? Well, conceptually, what it's designed to do is give you an expression that helps you calculate the slope of a secant line to a graph. In this video, what I'm going to do is derive the difference quotient. So let's begin. Let's say that I have just a random graph of a function, say such as this, and I want to look at a secant line. Well, first of all, I'm going to need 2 points, and those 2 points are going to come from this graph, and I'm just going to place them on it arbitrarily. Let's say I have a point right here and a point right there. And what I want to do is connect those 2 points with a straight line. Alright, so hopefully I can get this as straight as possible. Alright, so that right there is an example of a secant line, which I feel bad for my sister. She can't remember some of this stuff. But anyhow, what I'd like to do is figure out a way of calculating this line slope, and the way this is going to happen is using function notation. Alright, so this first point, the lower point, let's assume that it has a generic x-coordinate of x. Then if this is the graph of a function, its y-coordinate is going to be found by plugging x into the function. Namely, its y-coordinate is going to be f of x. So on this part of the y-axis, directly to the left of that point, the y value, generically speaking, would be given by f of x. So its ordered pair is going to look like x comma f of x. Now let's say that it takes me h units to get from the first point to the second point from a horizontal perspective. So basically what I'm doing is I'm going to add h units to this x right here. Let's just call this, we'll say plus h. And what that's going to produce for me is a way of labeling the x-axis tick mark right underneath that second point. And that x-axis tick mark is going to be given by x plus h. We simply add h units on to x in order to get to this location on the x-axis. Well, if we want to figure out the corresponding y value to this particular x-coordinate, we would plug that into the function as well. So the y-coordinate of this point, which I'm going to label on the y-axis, would be given by f of x plus h. So the ordered pair for this point is going to be x plus h comma f of x plus h. So here's where we're going to start to form the expression for the difference quotient. What I'm going to do is construct a right triangle out of these 2 points that are helping to form the secant line. So there's a horizontal leg and then there's a vertical leg. And there's going to be a way of figuring out how long each of these legs are. For the horizontal leg, you can probably see that, the length of that leg is going to be h units long, all right, because the length of this horizontal leg is the same distance separating x and x plus h on the x-axis. And remember how we got from x to x plus h, we added h units to it. So this horizontal leg's length is going to be h. As for the vertical leg's length, it would simply be the difference in the y values. In other words, it's going to be the same length as this distance separating f of x plus h and f of x. To get an expression representing that distance, we subtract. It's going to be f of x plus h minus f of x. In terms of some familiar jargon regarding lines and slope, the h represents an expression for run, and then the f of x plus h minus f of x represents an expression for rise. And so if we think about slope m, in kind of the old-fashioned way, is rise over run, we can replace rise and run with the lengths of each of these legs. Namely, the rise is f of x plus h minus f of x, and the run is simply h. And this right here is the expression representing the difference quotient, or I'll write dq for short. And there we have it, all right? A derivation of the difference quotient. If you have any questions whatsoever about this video, feel free to let me know. Otherwise, I hope this helps to demystify where that expression is coming from. I'll be sure to upload at least one video, including an example on how we would utilize it in a specific function. All right, other than that, thank you for watching, and I'll catch you guys in the next one.